Hi everyone, today we're looking at the binomial theorem and Pascal's triangle. So what is the value of 4C0? We learned about that in our lesson on combinations. Since NCR equals NCN minus R, again from that last lesson on combinations, we can say that 4 choose 0 is the same as 4 choose 4, and we know from a group of 4 there's only one way to choose that group. Okay. The binomial theorem uses combinations to give us a formula for expanding binomials. So if we had x plus y to the fourth, we do not want to have to do x plus y times x plus y times x plus y times x plus y. That's a lot of foiling. Chances of making an error would be high. So each part of the answer consists of 4 factors chosen from among the x's and y's in the brackets. One term consists of no y's and 4 x's. So to do that, we could say 4 choose 0, x to the fourth, y to the 0. The next term would have, so that first term would have been by me multiplying all of these 4 together, right, in this case. The next term, you'd maybe say, let's multiply the 1y by all the rest of the x's. So we could say 4 choose 1, x to the third, y to the 1. Okay, so most importantly, this would be the formula for the expansion of the full thing. And I just want you to look at the patterns here. So starts with 4 choose 0, then it goes 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. Look at the powers of x. It goes from x to the fourth, x to the 3, x to the 2, x to the 1, x to the 0. So the powers of x decrease by 1. What about the powers of y? They start at 0, and look, they increase by 1. Notice the patterns. Just talked about that. So you can write the binomial expansion as a general formula if you want. It kind of looks like this. This is given to you on your formula sheet. I'm not sure if you'll find it helpful or not. Most students just learn really well when we do this next example. So I'm going to get to that in a moment. Okay, so the example says expand and simplify a plus b in parentheses to the power of 5. So we start and we say, look, these were powers of 5. So we start with 5 and choose 0. So that's the starting step. We take our a, we raise it to the 5th power as we do here, and then the b goes to the power of 0. Notice the sum of these two exponents. 5 plus 0 is 5, just like we have over here. Up next, 5 choose 1. So what's happened to the combinations here? We went from 5 choose 0 to 5 choose 1, and then you'll see that pattern follows. Then it's 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. Now we said the first exponent decreases by 1. So here it became an a to the power of 4. What happens to the second exponent? It increases by 1. So it became b to the power of 1. Add those two exponents. They still add up to 5. Other interesting things. What's 5 take away 1? Oh, it's that first exponent of 4. What's 5 take away 0? Oh, the first exponent of 5. So over here, when we're at 5 choose 2, what should the first exponent be? 5 minus 2? Oh, look, it's 3. 3 plus 2 is 5. Going to the next line, 5 choose 3. So we continue to increase the r value here by 1. What happened to our a value? It was 3. Now it's 2. Or you can say it was 5 minus 3 is 2. 2 plus 3 is 5. 5 choose 4. A to the 1. Why a to the 1? Because 5 minus 4 is 1. B to the 4 because 4 plus 1 is 5. Finally, our last one, 5 choose 5. This time, 5 take away 5 is 0, so notice the exponent on a is 0 and the exponent on b is 5. Then it's just about figuring this out. So 5 choose 0 was 1, so we had 1a to the 5th. There were b to the 0 is the same as 1. The next term, 5 choose 1 was 5, and we have a to the 4th times b. The next term, 5 choose 2 was 10, so we have 10a cubed b squared. The next term, well, I know 5 choose 3 and 5 choose 2 have to be the same thing based on that very first point on this lesson. So we got 10 again, this time a to the 2, b to the 3. 5 choose 4, that's the same as 5 choose 1, right, which is 5, ab to the 4th. And finally, our last term, 5 choose 5 is 1, a to the 0 is also 1, so 1 times b to the 5th, just b to the 5th. Okay, so although that's the first time doing that, it would be much faster than you having to write out a plus b and FOIL that 5 times. Let's look at example 2. It says determine and simplify the first 3 terms of this. And look inside this time at our binomial, a couple of different things here, right? X minus 2y to the 10th. So we know we're doing combinations of 10. So for the first term, 10 choose 0. Then we do our this thing here to the power of 10. Notice the parentheses because our next term is negative. So negative 2y raised to the power of 0. Now the pattern continues. That's going to be term 1 once we simplify it. Term 2, instead of 10 choose 0, 10 choose 1. Drop the power by 1, x to the 9, increase the power by 1, here we get a 1. Final term, 10 choose 2, x to the 8th, I went down by 1, negative 2y to the 2. So let's see what happens. What's negative 2y to the 0? That's just 1, so this just simplified to x to the 10th. 10 choose 1 is 10 using your formula or your calculator. X to the 9, negative 2y to the 1 is just negative 2y. 10 choose 2 on your calculator, that's 45. X to the 8th. And then what's negative 2y when you square it? Don't forget to apply the exponent to both parts. So negative 2 squared is 4, and then we get y squared. Almost finished. We can do some cleaning up here. What's 10 times negative 2 here? That's where we got the negative 20. 45 times 4 was the 180. So there would be the expansion, which in this case, we only needed the first 3 terms as well. So definitely a lot faster than writing this out 10 times, foiling it, and then collecting like terms and figuring out the first 3 terms. Example 6 just asks us to find one particular term, the 6th term. So we look for patterns. We're looking at combinations of 12, so that's why we're saying 12. Why are we choosing 5? Well, think, if I'm doing the first term, I'm doing 12 choose 0, so that R value is always 1 behind the term number. So 12 choose 5 would give us the 6th term. How do I find the exponent that goes with 2a? Remember, subtract. 12 take away 5 is 7. Once I know that exponent 7, the one that goes with the 5b over 3, has to add up to 12, so 7 plus 5 would give us 12. Then it's about punching things onto your calculator and simplifying. So there's the answer that you can see we end up with. Look at example 4. In this expansion, find the term containing a to the negative 3. So what our strategy is going to be here is it's going to be to find the first couple of terms, figure out the pattern as to what's happening with the power. Then we should be able to figure out which term has a to the negative 3, and then we'll find that term just as we did in example 3. So let's do the first 2 terms here. So start out, we're doing combinations of 9. So we start with term 1, 9 choose 0. Take our 3a, raise it to the power of 9. So that's what we did next. Take our negative 1 over 6a squared. It gets raised to the power of 0. Okay, so what's the powers of a? Look in the numerator. I have an a to the 9th. So I just worried about powers of a here. I didn't simplify this fully. So I had a to the 9th in the numerator. What about the denominator? Well, I had a to the 2 to the 0. That's nothing. So we're starting out with a power of 9. Then we go to the second term. So instead of 9 choose 0, 9 choose 1. Our 3a is now raised to the 8th because 9 take away 1 is 8. Our negative 1 over 6a squared, it's raised to the 1. So look at the numerator now. There's going to be an a to the 8th in the top. Look at the denominator. What's a to the 2 when you raise it to the 1? Still a to the 2. So what happened to our exponent? A to the 8 over a to the 2. Subtract the exponents, we get a to the power of 6. So what's the pattern? We went from a to the 9 to a to the 6. We're going down by 3. So then we're going to have an a to the 3 for term 3, an a to the 0 for term 4. Term 5 is going to have a to the negative 3. So really this question up top now means find term 5. So let's actually do that. To get term 5, again, 9 choose 4 because we want term 5. We take our 3a, we raise it to the power of 9 minus 4, which is 5. We take our negative 1 over a squared, we raise that to the power of, well, these have to add up to 9, right? So this must be a 4. Get out your calculator, try 9, choose 4, do 3 to the 5th, a to the 5th, do this thing raised to the power of 4, and our answer simplifies to 189 a to the negative 3 over 8. So to summarize the steps in example 4, step 1, determine the power of a in the first 2 terms. Next, look for a pattern. What's happening to a? The power of a is decreasing by 3. Next, find the term number that will contain the desired power of a. In our case, that a to the negative 3 came about in term 5. Once you have that term number, just like the previous example, you can specifically find the term you're looking for. Okay, this next item is called Pascal's triangle, and it's very useful to help you find combinations without the use of a calculator. So if we check this thing out, you'll notice the border is all ones, right? And here's kind of how it works. So we have ones for these. To get this term that's in between, I say, oh, what's 1 plus 1? It's 2, right? So sorry, we had all ones on the outside. So that's how I'd start if I were trying to create this thing, right? Then in here, I'd say, well, 1 plus 2 is 3. Over here, 1 plus 2 is 3. Go to the next line. What's 1 plus 3? 4. What's 3 plus 3? 6. What's 1 plus 3? 4. Go to the next line. 4 plus 1, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. So you can get the idea. This pattern follows all the way down. Okay, so why is it useful? Okay, so let's take a look and see. So this can help us find combinations. So say I wanted to find 6, choose 2. Okay, so if I want to find 6, choose 2, a couple things you would want to know. What row am I going to look in? I'm going to look in the 7th row. This is combinations of 0, 1, 2, 3, 4, 5, 6. So just think the top one, 0, choose 0. This one, 1, choose 0, 1, choose 1. 2, choose 0, 2, choose 1, 2, choose 2. 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. So if I want 6, choose 2, go down where the second one's a 6. So here's choose 0, choose 1, choose 2. So there's 6, choose 6C2 is 15. You can try it on your calculator, you're going to get 15. Okay, so 7th row, position 3. What if I said find 12, choose 10? Okay, I'm going to have to go to the 13th row, 11th position. Or sorry, yeah, 13th row, 11th position. So let's see here. Oh, down. Combinations 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, choose 10. So that's choose 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see that 66 corresponds to the actual value of 12, choose 10. If I said 8, choose 3, go down. It's an easy way to find what row the 8s are is look at the second position. That's the same for anyone. If you're wanting the combinations of 11, look where the second one is 11. Okay, so here's 8, choose 0, 8, choose 1, 8, choose 2, 8, choose 3. 56. So that's Pascal's triangle. That's how it works. It's got all sorts of neat patterns in it, and it's very useful for finding combinations. It's really easy to recreate as well. Okay, I think that concludes our lesson on Pascal's triangle and the binomial theorem. So time for you to practice some questions from section 8.4. Talk to you guys again soon.